So this is network monitoring with InfluxDB. Charles, I'm a technical writer at InfluxData. So what we're going to be going over during this session is basically the challenges in network monitoring, some common pain points we see. We're then going to go into how InfluxDB and its surrounding ecosystem can help solve these challenges. And then finally, we're going to go over some real-world use cases and see how people are using InfluxDB for network monitoring. So to start, the big kind of challenge is collecting the data in the first place, especially at enterprise level. You have people dealing with legacy hardware. They have different operating systems, different amount of hardware resources. They also have issues with like vendors can have their own protocols, which can create a lot of extra work trying to integrate all those to collect that data. You're also going to want to standardize that because it's coming in from different sources. You want to make sure it's all uniform. And in some cases, you'll also want to enrich that data, maybe add some additional information to those data points to get more context. It's really the most important part because no matter what else you do, whatever fancy tools you're using, if your root like data source isn't good, if it's low quality, it's pretty much impossible to make good decisions based on that data. So once you've got that all set up, then you move on to how you're going to store that data. So you have to deal with the question really of cost versus complexity. So everybody wants really granular data. Obviously, that would be for the best, but you also have to balance with how much it costs to store that data. In the past, it wasn't uncommon due to various just hardware limitations to maybe take 5-minute interval data points. That's where you'd collect from. Now, most companies, it's not uncommon to do minutes or even in some cases sub-minute intervals, and InfluxDB supports down to nanosecond precision. So it really depends on your use case, and you just have to kind of decide how to balance those trade-offs. As far as complexity, how you choose, what database you choose, how that scales, how much work you have to do, that's another thing you have to take into consideration. Ideally, you don't even want to think about it. You don't have to worry about it. You just ingest your data and it just scales on its own. Finally, the other challenge is analyzing that data. So you need good performance from your database. You want queries to return quickly so that whether it's a developer or a business analyst, they're not getting frustrated waiting for some result to return. You also want tools in place so that you don't necessarily need to be an expert to kind of work with the data and get insights from it. And then finally, you want to be able to take action on what your data is telling you without a bunch of effort required. So how can the InfluxDB ecosystem kind of help solve these problems? So here's a kind of high-level picture of the InfluxDB ecosystem. So the rest of this presentation is going to be going over how you can use each part of these platform to help with network monitoring. And in some cases, you can pick and choose. You don't have to use the entire stack. You can use whatever works best for your situation. So for the data collection issue, first off, we have Telegraf. It has over 300 plugins, and it's especially useful for network monitoring because it has support for protocols like SNMP, Gemini, and a bunch of vendor-specific protocols. So you have one tool. It just takes all that data in. You can transform it. You can manipulate it a little bit. And then you can send it off to wherever you want to store your data. Big bonus for many users, which we'll cover in a few slides, is the processor plugins that come with Telegraf so that you can do some of that data enrichment, or you can do just stuff like standardizing the data. If it comes from a different vendor, you can make sure that they all match up. They might have different names for the same metric. You can rename those fields and it's all uniform. We also have our kind of ecosystem integration. So a lot of projects now natively integrate with InfluxDB. It could be things like Apache NiFi, there's Vector, and a lot of projects also just support line protocol directly. And InfluxDB also has scrapers itself. So like, for example, the Prometheus scraper. So any project that uses those types of endpoints or provides those standard types of ways to grab data, Influx also supports like push and pull that way. And finally, you have the client libraries, which pretty much every popular programming language, there's either an official one that we support or there's a community client library. Out of the box, you get best practices like batching, retries, and error handling. But if that's not your thing, we also have direct access through the REST API, where you can kind of build your own client, or you can just interact with it directly, and you have more flexibility that way. And we also recently just released our native collectors. Currently, it just supports MQTT, but over time, there's going to be more protocols added to that. So that's another way to kind of collect your data. So now we're going to look at some different Telegraf deployment patterns, because this is, for network monitoring especially, a pretty popular way to collect data. So one option is per device, like a sidecar type pattern, where for every network device, every server, whatever you're collecting data from, that gets its own running Telegraf instance, and that can be deployed via Docker, or it can be deployed as a direct installation on the hardware. And at large scale, you're going to want, obviously, some automation in place so that if you roll out a configuration change across the whole kind of fleet, you want your Telegraf instances to be updated. So you want that in place if you do it this way. But the other benefit of this way of deployment is that you get you can shut down or customize each one for each machine, and you don't have to take down polling for like multiple machines like you'd get with the single Telegraf instance. So that gives you a little bit more flexibility that way. On the other hand, Telegraf is very performant, so it can definitely handle taking in metrics from multiple devices. It has great performance, so generally not going to be an issue unless you're running like a ton of different processor plugins. So the big takeaway here is it just comes down to flexibility, especially now with the Telegraf custom builder. It has a very low footprint, has a bunch of different ways you can deploy it. So it really just comes down to whatever works best for your situation. Specifically, some different processors for Telegraf that work well for network monitoring. The use cases being normalizing data, enriching data, and you can also filter and rate limit data. So for normalizing data, an example of this would be like some like BGP metrics. They might, depending on the vendor, hardware, be telling the same thing but have a different name, or they just might have excess fields you don't really care about. So with Telegraf, you can use different processing plugins to either just drop a field, rename it using like the regex processor, or you can also map fields to values using the enum processor. So maybe they return just like a number, like a 0 or a 1 or a 2. You can map that to like an actual string. So then when whoever is looking at it later in a dashboard, they have a little bit more context with like a proper name for what's happening. As far as enriching data, you can use like the exec plugin, which can allow you to run pretty much any script, just like it's a command line input-output. So you can run like a Python script, grab some data over REST API, return that, and then join that together with whatever metric you're using. And then finally, you have in the configuration, you can mess around with like the buffer size, the interval configuration, and you can do that to kind of sample data or just rate limit data to whatever really you want to do with it. So now on to data storage. So we have our data collection in place. Where do we want to send it? Obviously, you have many options. Big thing is, again, choosing. It's like the balancing act of like ideal storage cost, and also you don't want to worry about like complexity of managing your database. So here, as far as InfluxDB goes, one of the big things is the compression and just the way it stores data. It's able to really minimize some of your storage costs compared to a more standard database. So that's going to save you money just purely on your data. It means you can store more data for less money. And it also has built-in stuff like retention policies and downsampling. So like after a set date, if you know you don't need that data anymore, you can throw it out, which again saves you having to either like manually do that or build that feature yourself. And for like downsampling, you can still kind of get the best of both worlds. You still have that data on hand, but you've reduced the size of it. Management, like complexity, so that comes down to scaling. Does it horizontally scale? Do you have to manage a bunch of stuff? Do you have to dedicate developer resources to kind of dealing with that stuff? And also a big thing as part of being open source is that InfluxDB gives you a lot of flexibility in terms of how you deploy it. So that's another thing with kind of the complexity aspect, which we'll look at on the slide, is that really you can make it fit into your architecture no matter what you're doing. So what this is showing is that for certain use cases, if you care about like short-term data, you can use an OSS instance and then get very fine-grained data, process it, do your alerting, your real-time monitoring stuff on OSS. And then you could theoretically, with our new feature for edge data replication, you could send data to the cloud after you've looked at it locally with low latency. You can also do stuff like, really when you think about it, you look here, so this also shows how you can do processing at many different layers of the stack with InfluxDB. So we just think about a few potential options here by combining OSS with cloud. You can use Telegraf, like we said earlier, we talked about it, where you can process it directly with Telegraf. You can use those plugins to do some stuff. You could also use Telegraf to send it to like a more dedicated stream processing tool. You could then have Telegraf listen for those results to be returned, and then Telegraf sends it to InfluxDB. You could send stuff to InfluxDB and then use Flux to process and transform that data inside InfluxDB. Or you could just combine that again. Flux is able to reach out to other stuff, other databases, other kind of services. So you can pull additional data once it's been stored in InfluxDB back into Influx and do stuff with there. So really it comes down to you have so many different tools for how you can mix and match and whatever fits your architecture best, whether it's at the edge, whether it's in the cloud, but there's a lot of different ways to tune things for whatever works best for your situation. So finally, we're on to kind of analyzing data and how InfluxDB can help you with that for your network monitoring situation. Querying is obviously important. So big thing that we've seen is really you don't realize until you've kind of switched to a more performant database, like the benefits of it. So we've had users who, once they moved and once they saw how much faster the queries are, they actually had people that weren't doing anything with their like monitoring data before, but because it didn't take 5 minutes to get a result back now, people started playing around with it and they started finding a bunch of different like insights and a bunch of value from that data, just because now it was being stored before, but it wasn't really, no one bothered to use it just because it was such a pain. You also see people will say they have a stated goal for like, we're going to store 1 minute resolution data, and that's their stretch goal and they're going to be happy with that. But once they get this performance and they realize, hey, we can keep scaling this, it's not going to be an issue. Then they say, oh, why not store at 1 second or even sub-second granularity, because we can still query it quickly. We can still find more insights with that. So it's kind of the demand for data always keeps rising with performance. And it's kind of like it's similar with developers, where we always find new ways to like use hardware resources when it comes to building applications. So it kind of opens up entirely new possibilities just having access to that performance. Again, allowing non-experts to be able to work with that data, that's a big thing too. There's no point just storing data that nobody touches and that no one bothers with. You want people to be using it. So you don't want to have to be a developer or like a statistician to gain insights from your data. So one big thing is like the query builder. Even if you don't know Flux that well, or even if you're not a programmer, you can play around with the UI. You can build those queries and basically just dynamically it'll show you the fields, stuff like that. And you can build and create visualizations, basically just point and click. We've also added recently, or will be adding, Postgres wire compatibility. So that's going to open up a bunch of new tools, a bunch of new integrations that different users will be able to access their data through. And Flux, out of the box, has a lot of statistical and analytical functions. So even if you're not the strongest in that area, you can still kind of just throw your data into those functions and you can look at the result and kind of build some stuff based off those. So out of the box, a lot of ways to get insights from your data. And finally, acting on your data. Once you've got that, like you want to be able to pretty easily set stuff up to actually take action on those new insights you're getting. So things like alerts, tasks, it's built into the platform. You don't have to reach out and use some other service. You don't have to connect another service. It's just out of the box. You can dynamically act on your data. You can integrate all sorts of things. You can create alerts based off that. So it's just really nice from a usability perspective. So now we're going to dive into those use cases. So in particular, we're going to be looking at security monitoring. So some pretty interesting cases of how Influx also like dog food's our own product, how we use it for some security stuff, so behavior modeling, intrusion detection, and then we'll look at some performance monitoring cases for things just basic kind of reducing toil, reducing routine tasks, improving efficiency, and finally look at how to like forecast and try to predict the future based on your data. So first we're going to look at kind of an example in the wild of a security incident and how it could have pretty easily been prevented, and something that our own team does internally that could have helped prevent this. So in a lot of cases for security stuff, it's really simple things that could be prevented pretty easily. And so what's happened here is the company that got hacked, it was a CI/CD tool, and they got hit by a supply chain attack. It went undetected for 4 months until a customer actually notified them what was happening. And the takeaway was that it could have been easily solved because it was root caused by 2 IP addresses that were accessing thousands of different customer accounts, and they were downloading just huge amounts of data from this application. So what we do internally is kind of a way to dog food InfluxDB is where you could show an example how to find this. Is just basic anomaly detection, where our security team has created some custom stuff to create real-time alerts, and they just monitor the different kind of supply chains, different SaaS tools we use, and they convert logs into basic kind of line protocol. They convert those, put them into InfluxDB, and it's really simple in the sense that they just look at things like authorization attempts over time, unsuccessful, like failed authorization attempts, how many IP addresses are trying to use an account, and how many accounts are there per IP address. So simple thing like that, which really isn't that hard to set up. Like it's a basic kind of analysis. Like if you all of a sudden out of nowhere you have one IP address logging into 1,000 different accounts, that's pretty easy to figure out that it's not normal behavior. And beyond what we do internally, as far as security goes, we also have several companies that build on top of. So cybersecurity companies that use InfluxDB as kind of a critical building block of their product. They, under the hood, are using InfluxDB to store some of their event data related to security type monitoring. So whether you're just building something for yourself or you're looking to build a platform to provide a security service to other people, InfluxDB provides a pretty good foundation. Now, for performance monitoring, we have 2 fairly good, fairly well-known examples. So you have Cisco. They use InfluxDB for several different kind of tasks. They use it for their e-commerce platform, which helps kind of track the renewals. So they use that for uptime monitoring, availability, your basic kind of DevOps and monitoring type stuff. They also use InfluxDB for monitoring their Cisco Live Conference. So that you can see they have some pretty cool metrics in the sense that they have 2,300 different wireless access points, 650 switches, and over a 5-day conference period, they do 76 terabytes of network traffic, and they use InfluxDB to kind of track all that. Red Hat, again, they use it for their own internal network monitoring. They use it for real-time monitoring, network visibility. They have 60 different locations that they track, and they have 1,600 network devices and 1,400 or 14,000 network interfaces. So a big reason they like it is they use Flux for anomaly detection, kind of like earlier we talked about during the security thing. So they can look for weird activity in their network. They can also do capacity utilization. They use it for kind of projecting what kind of hardware they're going to need to meet demand. And they do some compliance reporting and then just track their SLOs and things like that. Finally, so we have InfluxDB for forecasting. And I think alerting and monitoring is cool, but the end goal really with time series data is you want to use the past to try to predict into the future and be more accurate. So for a network monitoring use case, you have capacity planning is pretty common. How much hardware based on historical traffic, our rate of growth in traffic, how much hardware should we kind of allocate and buy ahead of time to make sure we can meet demand. So renewable energy is another kind of use case for forecasting with time series data, One example of this is one of our customers, Graphite Energy, and what they do is they take peak kind of production when solar panels and wind are producing too much. They convert that into thermal energy, which can be stored, and that helps with like one of the big problems with renewables is they don't provide like a steady flow of energy. It'll peak very high, and then like at night for solar panels, it's not producing anything. So what Graphite does is they help kind of even that load out, and they sell that power to industrial kind of manufacturers that need a steady provider of energy. So it's a win-win for both of them, and they use InfluxDB a lot at the edge for their generating power, and also in the cloud for like making these forecasts in the future, like where should we be investing? Is solar doing better than wind? These sorts of things. So they use it both for like real-time monitoring at the edge, and then for long-term like historical analysis using cloud. Finally, we have predictive maintenance. So for manufacturing companies, any downtime is going to be a big loss. So they want to be able to repair things before, like ahead of time, before they break down. And one customer we have that does this is AdLink. And what they did is there's a customer they had that lost like over $100,000 every time a machine broke down because they'd need to call in like a specialist to repair this machine. That'd take a while. So what they did was they used InfluxDB on the edge. They hooked a bunch more sensors up to these machines, and with that extra data, they're then able to see, okay, why is this thing? They're able to predict ahead of time, like, okay, this correlation, it's potentially going to break down in the near future. So instead of having to wait hours for this repair specialist to come in and fix the machine, you can preemptively place the call and just have them fix it ahead of time. And then you don't have that downtime on your machinery, and you save a bunch of money. So that's it for this presentation. Thanks for listening. Hopefully you picked up something useful. And if you're interested in learning more about network monitoring or InfluxDB in general, be sure to check out our website, some of our case studies. There's a bunch more like the ones I kind of covered briefly. And we also have a lot of customer webinars that people like.